All right, so this one said to find the vertex of the function. I don't want to put this into standard form by going complete the square route, which means I use my other route, or the negative b over 2a route. So if h equals negative b over 2a, and a is 4 and b is negative 4, then I would get negative 4 over 2 times 4, and I end up with 4 over 8, which is 1/2. So the x coordinate of my vertex is a positive 1/2. Then I take and plug that in, and I get 4 1/2 squared minus 4 times 1/2 plus 21. 2 goes, oh sorry, let me square that first. Minus this 2 goes into 4 2 times plus 21. 4's cancel, 1 minus 2 plus 21. This is negative 1 plus 21, which is 20. So if you are to graph, let's say you want to graph this function, okay, and it's not factorable, so I'm not going to go through the whole process. But now realize that you've got options. You can either force this into complete the square, find your vertex, find your intercepts that way, or you can leave it the way it is, find your vertex using the negative b over 2a, find your intercepts, speaking faster than I can write, intercepts by factoring, or again using the quadratic formula if it's not factorable, and both your x and y intercepts. And then you can graph using that stuff and any additional points. So there's 2 ways to graph these functions. If they're in standard form, then you're going to find the vertex using the HK pulled out of the equation. And then you're going to find your intercepts either, well, you wouldn't be able to factor if it was in standard form. You'd find the intercepts doing the even root property and then graph it. If it's in quadratic form, then you can find the vertex by doing negative b over 2a and find the intercepts by factoring and then graph it. Or you can force it into standard form. Obviously, it's easier to do standard form if either there's not a number on the front of the x squared, or if it's something like this where the number on the front of the x squared will go into the second term. It's not so bad, okay? But just keep that in mind. You now have like 2 strategies to doing that stuff. Okay, here's the difference quotient for I period from the test. So you had to do f of x, which is f of x plus h. Take the x plus h and plug it in. So 5 times x plus h squared minus 3 times x plus h plus 2. That x plus h squared is x squared plus 2xh plus h squared. Distribute the negative 3. 5x squared plus 10xh plus 5h squared. Cancel through the 5x squared and the, oh, not yet, sorry. Subtract from this my f of x, which is this whole thing. Change all the signs that follow. The negative and the positive 5x squared cancel out. The negative and positive 3x cancel out, and the negative and positive 2 cancel out. And I get 10xh plus 5h squared minus 3h. Last step, all over h. H cancels. 10x plus 5h minus 3 is the correct answer for that one. Okay. Then comes the other version, which was 4x squared minus 2x plus 2. So this is 4x plus h squared minus 2x plus h plus 2. 4x squared plus 2xh plus h squared. Distribute the negative 2. Distribute the 4. Subtract from this your original f of x. So subtract this whole thing. It's going to change the signs of the 4x squared, the 2x, and the positive 2. All those signs change. Positive and negative 4x squared cancel. Positive and negative 2x cancel. And positive and negative 2 cancel. And I get 8xh plus 4h squared minus 2h. Last step is put it all over h and then cancel the h's from each term. And I get 8x plus 4h minus 2. Okay, j period. So this was 2x plus h squared plus 4x plus h minus 3. Expand the x plus h squared. Distribute the 4x. Distribute the 2. Subtract from it my original f of x. So 2x squared plus 4xh plus 2h squared plus 4x plus 4h minus 3. And it changes the sign of all of them. So minus 2x squared minus 4x and plus 3. Positive 2x, negative 2x cancel. Positive 4x, negative 4x cancel. Positive 3 and negative 3 cancel. 4xh plus 2h squared plus 4h all goes over h. And an h cancels from all the spots. 4x plus 2h plus 4. Now repeat that for the other version. 2x plus h squared minus 4x plus h minus 7. Expand and FOIL this one, and I got that. Distribute the negative 4. Subtract from this my original f of x, changing all of its signs. So negative 2x, positive 4x plus 7. 2x and 2x, positive negatives cancel out. Negative 4 and positive 4. Negative 7, positive 7. 4xh plus 2h squared minus 4h all over h. Cancel that in, and I get 4x plus 2h minus 4. There's that version. Okay, here's C period's difference quotient. So remember again, f of x plus h minus f of x over h. So first thing I'm going to do is plug in that x plus h. Expand and FOIL it out. So 5x squared plus 2xh plus h squared. Distribute that negative 2. Distribute the 5. Subtract from it my original f of x, changing its signs. Cancel the positive 5x squared, the negative 5x squared, the negative 2x, the positive 2x, the positive 6, the negative 6. 10xh plus 5h squared minus 2h all over h. And an h cancels from each spot. And I get 10x plus 5h minus 2. Okay, last one in C, 3x plus h squared minus 2x plus h plus 6. Expand, distribute, distribute. Subtract from this my original f of x, changing all of its signs. Cancel the positive 3x squared, the negative 3x squared, the negative 2x, the positive 2x, the positive 6, the negative 6. Put it all over h. Cancel one of the h's, and I get 6x plus 3h minus 2. We are going to start 2-2. This is another beast of a section. It's going to take us the 2 days to do it. And then at the end of this is where we'll stop. This is where your quiz will take place. So the quiz is going to be 1-6 to 2-2. Let me just check my time. 8:40. Okay. To 2-2, and then you're going to get part of it is going to be the complete the square. That's going to be a video component that you'll go home with over the weekend. And then on Monday, you'll take the quiz on the rest of the stuff, okay? So this section teaches you how to graph functions of a higher degree. These graphs go up, down, up, down. They go down, up, down, up. They could just be parabolas. They're all sorts of different kinds of graphs. But they are always continuous, which means no starting and stopping. These are not piecewise functions. These are continuous, okay? The degree is 2 or higher, meaning it's x squared or x to the third or x to the fourth or x to the fifth. These are not lines. They are smooth and continuous, meaning I can put my stylus or my pencil to start graphing it and go all the way through the curve without lifting it up and starting it again. There's no sharp corners, so you won't see anything that goes like up, down, like that. There's not going to be any sharp corners. It will be smooth there in both of those spots. And there's no breaks. Okay, it can be drawn from start to finish without lifting your stylus or your pencil. So the top left, these are examples of graphs of polynomial functions of higher degree. The bottom right are not. So notice that this has a break in it. This has sharp corners. Okay, you should not see things like that. They should be smooth and continuous. There are monomials. Monomial means one term, okay, that we can actually graph based on transformations. So this is the simplest polynomial graph. There's only one variable. It's raised to a power. It can have a number on the front of it. It can have a number added to it, that kind of stuff. But there's only one variable. If the n is even, it resembles the graph of the x squared, meaning it resembles a parabola. So if it's x to the fourth or x to the sixth or x to the eighth or x to the 10th, it resembles a parabola. If it's odd, then it resembles the graph of the x cubed, which would point up to the right and down to the left. The higher the exponent, the flatter the graph is near the origin. So if I were to graph both x squared and x to the 10th, let's do x to the 10th. X squared would go up 1 and right 1 like that. That would be perfectly like in your normal shaped curve. X to the 10th would also do 0, 0, 1, 1, but what happens in between is it's almost flattened out. Okay, so that's the only difference basically between those. Obviously, it increases faster once you get past 1, but it's flattened out more on the bottom. That's all you have to know. If you were to graph those two on top of each other, the x to the 10th would be flatter in between the 0 and the 1. Because if I took something like a half and I square it, I get a fourth. If I get a half raised to the 10th power, right, that's, I don't even know, 250, no. If I did 2 times 2 times 2 times 2 times 2 times 2 times 2, whatever, 10 times, that fraction is going to get smaller, which means it's going to be closer to my x-axis, which means it's going to flatten out. This would be 1 over 1,024. So it's going to be smaller and flatter in between the 0 and the 1. You don't have to know exact points there. You're just kind of doing an approximation. All right, so this says sketch the graph. This first one is x to the 7th plus 1. So because it's x to the 7th, it's going to be in the shape of a cubic function. The plus 1 means it shifted up 1. So I shift up 1, and I make it like a cubic function. That's it. Transformation. You won't do a lot of these, but just know they exist. X minus 1 to the 4th means it's going to look like a parabola, okay? The minus 1 inside goes right 1. So I go to the right one, and I draw a parabola. You with me so far? Those are only if there's only one variable, okay? Then we get to what happens if there's not. So there's a couple of different things we're going to identify as we move forward into graphing, and the first is called end behavior. So the end behavior of a polynomial function is how my function starts and stops. Now this looks a lot more complicated than it should be, okay? But the big thing is the n is the highest exponent. That's the degree of the polynomial. It's called the degree. But it really is the highest exponent. So there's two cases happening here. One is if the n is odd. One is if the n is even. So if I have an x to the third or an x to the second, let's say, if it's odd, one of my arrows is pointing up and one is pointing down. If it's even, both are pointing up or both pointing down. Think about your cubic function and your squared function in your head. My cubic function goes up, right, down, left. My parabola goes up and up. Same process for if it's anything bigger than 2 or 3. If it's odd and the leading coefficient, which is the number on the front of the x that has the highest power, is positive, then it rises right and falls left. If it's negative, it rises left and falls right. If the exponent is even, and that leading coefficient, the number on the front of that exponent, is positive, they both point up. And if it's negative, they both point down. This says that exact same thing. For an odd degree polynomial, they have opposite behavior at the end. If a is positive, so this is a x to the n, that's the term we look at. If my n is odd and my a is positive, then it falls left and rises right. If my a is negative and the exponent is odd, it rises left and falls right. If it's an even degree polynomial, they have the same behavior at the end. If it's even and positive, they both point up. If it's even and negative, they both point down. This is just the end behavior, meaning how it starts and stops. All right, so example 2, use the leading coefficient test, which is the end behavior test, to determine the end behavior of the graph. First thing I have to do is look at this polynomial and ask myself, is it in order of highest degree? Because it's not always going to be the first one. So you want to find the one with the highest exponent. This time it is first. Is the exponent on that even or odd?
Odd.
Odd. Is the leading coefficient on that odd exponent positive or negative?
Negative.
Negative, which means this falls left. Nope, it rises left and falls right.
Wait, which one's the leading coefficient?
The leading coefficient is the number attached to the x that has the highest exponent. So if this was negative 4x minus 3x to the third plus 7, this is still that's still the term you want to look at, the one with the highest exponent. The number on the front of it is the leading coefficient. So this graph would rise to the left and fall to the right. We'll use these words: rises left, falls right. Next up is the zeros of the function. The good news is we already know how to do this. In a polynomial function, the values of x for which f of x equals 0 are called zeros. Remember, they're also called roots, solutions, and in coordinate point form, x-intercepts. So all of those mean the same thing. If it asks you to find the roots of the equation or the zeros of the equation or the solutions, you set your function equal to 0 and you solve it, which means you're going to factor. Okay, so example 3 just says find all the zeros of x to the third plus 2x squared minus 4x minus 8. What do we do when there's 4 terms?
Group.
Good. Factor by grouping. So from my first set of parentheses, I can take out an x squared and I get x plus 2. From my second set of parentheses, I can take out a negative 4 and I get x plus 2. Now x plus 2 is my greatest common factor, and I group together the x squared and the negative 4. Is that as factored as it gets? Nope, I've got the difference of 2 squares. X plus 2, x plus 2, and x minus 2. So solve it, I get negative 2 again, and positive 2. When I list my zeros, I only need that negative 2 once. But it is important, and you'll see it in a second why, to identify that it happens twice. So we only need to list it once, but that's called something that's called multiplicity, and it's going to affect my graph. We good so far? All right, so this is multiplicity. The multiplicity of the x-intercepts is the number of times the root occurs. So if it occurs more than once, obviously, if it's just once, then that's just once. But if it occurs more than once, it's called the multiplicity. If a root occurs an even amount of times, then the graph hits the x-axis and turns at that point. A lot of times we call this bounces. So it bounces off that point. If it occurs an odd amount of times, then it crosses through the x-axis. Is how many times your function changes direction. Does it go up and down? Does it go up and stay up? Does it go up, down, up, down? Each of those would be a turning point. So if a function is a polynomial function of degree n, then it has at most n minus 1 turning points. So if my exponent is the third, it has at most 2 turning points. It could also have 1. But it has at most n minus 1, okay? If it has 1, it means there's an imaginary root, which is possible, okay? But that's why the words at most are there. So if this says this is x to the 5th is the highest exponent here, this has 1 turning point because it goes from increasing to decreasing, then it goes decreasing to increasing. That's a second turning point. Increasing to decreasing, that's a third turning point. Decreasing to increasing, that's a fourth turning point. So that's the most amount of turning points it can have. Okay, we're going to get started on this question and then I'll let you go. This says, find the zeros, determine the multiplicity, determine the maximum number of turning points, and then use a graphing utility to verify. So I'm going to take we already found this, right? This is the one we grouped. We took out the x. So we already did this. That's why I'm going through it fast. We said x plus 2, x squared minus 4, and then we factored that one more time. And then we solved it. So now we have to pay attention to, those are my zeros, negative 2 and 2. But the multiplicity of that negative 2 is 2. So when I write it out, that's how I do it. I just do negative 2, I put a little 2 and I circle it. That reminds me it has a multiplicity of 2, which means it's going to bounce off my graph at negative 2 and cross through at positive 2. The maximum number of turn points, my n is 3. So the maximum number of turn points is 2 because it's n minus 1. And if I graph this on a graphing utility, when I graph it, that's what it looks like. So notice I've got zeros at negative 2 and positive 2. It bounces off negative 2. It crosses through 2 because of my multiplicity. And there's 1 turn point, 2 turn points, 2 max turn points. So tomorrow we're gonna actually put all that together and learn how to graph these by hand, but you can get a head start on the homework. I will tell you again, if you save it all for tomorrow, it's gonna feel like a lot. So get a head start because there's questions just on end behavior and zeros, okay? That homework is due Friday. So I grouped it all together because I didn't know how far we were gonna get, honestly. And that homework's due Friday. Jacob, you had a question?